Hey guys. So last time we were working on the PowerPoint, we ended up on page 5, and here's my typed answers. And this time, instead of doing it on the PowerPoint, I'm going to pull up my document, which looks like yours, that I can type in, that you should also be able to type in. And I'm going to show you where to type, what to do it, or even if you have to write it out on a sheet of paper, write it on a sheet of paper. All right, so the first thing it says, directions, name all sets of numbers to which each number belongs. This is nothing new. This is what we were just talking about. So 30, how far up the pyramid can we go? So if I click back at my pyramid, is it a negative, positive, fraction, decimal, or zero? Yep. Is it an integer? Yes. Is 30 a whole number? Yes. Is it natural? That means it's a positive whole number and I can count to 30. So yep, that's what I'm going to list. So it says name all the sets, but what I'm going to do is let's keep it easy and just name the most specific set. So let's say natural. Number 2, negative 11. Well, the furthest up I can go is integer. Because once I get to positive numbers, that's what's above integer is whole number, and it's not a whole number. 5 and 4 sevenths. Well, I can't simplify 5 and 4 sevenths. I could turn it to a decimal, but that's just going to be rational. Because above rational is integer, and it has to be just a whole number, positive or negative. All right, the square root of 21. Can I solve that? No, I can't. So that means it's irrational. Now keep in mind that all these numbers are also real. Rational and irrational are all real. 0, how far up the pyramid can I go? Is it an integer? It sure is. Is it a whole number? Yes. Some of you would say that it's not, but it is because you can have 0 wholes. The negative square root of 9, when we talked about where that negative sign is. So the negative square root of 9, that means they want the negative answer. So that's negative 3. So how far up the pyramid can I classify negative 3? So I'm going to say negative 3 equals, that's going to be an integer. 6 thirds, can I simplify that? Well, that's technically 6 divided by 2. So that's 6 divided by 3, which is 2. So how far up the pyramid can I classify 2? Would you naturally count to 2 if you started counting? Why, yes, you would. So it's natural. Pi, that is the poster child for irrational numbers because it never ends, never repeats. Now 5.3 with that bar above it, now y'all know that means repeating. So it repeats, and because it does repeat, there's a pattern, meaning that it is rational. So as long as it repeats, it's going to be rational. We're going to do the same thing here. So directions, place the letter of each value and its location in the real number system below. So we're going in the most specific, and this is just like the pyramid thing, except it's upside down. So natural was at the top of our pyramid, and then whole, and then integer, and then rational. And then irrational is all the way over here by itself, just like it's in its own pyramid over here. All right, so we're looking at A, 7. Well, would you naturally count 7? Yeah. So we're going to say A goes underneath natural. B, negative 36 over 12. Well, can I simplify that? 36 divided by negative 12. Positive divided by negative is a negative. And that's going to leave me at negative 3. So really, I'm classifying B as negative 3. Would I naturally count negative 3? No. Is it a whole number? No. You can't have negative things. Is it an integer? Yes. So negative 3, which is B, is going to be an integer. The negative square root of 36, we just talked about that. So what's the square root of 36? 6. Put a negative in front of it. So again, I'm classifying it as negative 6, which is an integer as well, comma, C. D, the poster child for irrational numbers, which is pi. E, 6.48. It's a weird number, right? Because it's a decimal, but it's a decimal that ends. So as long as it ends or repeats, it's going to be rational. So we're going to go up here to rational and type E. F, negative 2. Well, it's rational. It's also an integer. Is it a whole number? Nope, can't have negative wholes of anything. The negative square root of 10. Well, is there any number multiplied by itself that's going to give me 10? No, so I can't solve for the square root of 10, regardless of that negative sign or not. So that's going to be irrational. I put it under irrational. That's where it should be. All right, so H is 0. 0. Can I have 0 whole pizzas? Yes, I can. But if we go to start counting, naturally counting, if you're playing hide and go seek, do you say 0, 1, 2, 3? No, you don't. So it's just the furthest up the pyramid, or the most specific category we can list 0 is in whole. So it's H in whole. 2 and 1/6. I cannot simplify that 1/6. That's just going to be rational. Negative 0.7 repeating. Now that decimal never ends, but does it repeat? If it repeats, it's going to be rational. And then the square root of 4/81. Now we talked about this, maybe not. Maybe we're getting ready to. I don't remember. But whenever you have a fraction underneath the radical, you take the square root of both the numerator and denominator. So what is the square root of 4? It's 2. What's the square root of 81? 9. So that's going to be 2/9. Well, anything that you can write as a fraction or a ratio is going to be rational. So K goes up here as well. And we're done with this section. Number 1 says, which expression does not name an integer? So integer, we're looking for positive or negative whole numbers. Is this a positive or negative whole number? Yep. Oh, and 0's in there too, so that works. 6/14, can we simplify that? No. What about 12/6? That's 12 divided by 6. 12 divided by 6 is 3. Is 3 a positive or negative whole number? Yeah, it is. So the only one that's not an integer is going to be, B. And somewhere, there it is, I put a box for you to type in. So B is the answer. Number 2, which expression represents an irrational number? So irrational is going to be either a square root of a non-perfect square that we can't answer, or pi. Okay, so this repeats because it's repeating, it's rational. This is a fraction, ratio, rational. And then D says the square root of 3 minus the square root of 3. Well, that's irrational. This is irrational. But what happens when we take anything and subtract it from itself? 2 minus 2 is 0. 20 minus 20 is 0. So anything minus itself is going to be 0. So 0 is actually rational. Remember, we classified it as a whole number. But the square root of 75, I cannot solve, so that is going to be my irrational answer. So B. Which number is not a whole number? Well, 8's a whole number. Can you have negative wholes? Nope. Okay, well, let's check this. 0. You can have 0 whole pizzas. You can have 0 wholes. And then what about 18 divided by 3? Well, 18 divided by 3 is 6. So we're actually categorizing 6 as a whole number. So the only non-whole number there is going to be B again. Looks like we have a pattern. Which of the following is a true statement? Negative 9 is a whole number. Well, we just talked about how you can't have negative wholes. So A is not true. The square root of 25 is an irrational number, meaning that we can't solve it. But you know what the square root of 25 is. It's 5. So 5 is actually rational. It could be all the way classified under natural. 0 is a natural number. Well, do we naturally count 0? 0, 1, 2, 3, 4, 5. No, we don't. So that one's going to be a false. 2/3 is rational. Ratio, fraction, rational. Great. So which is the only one that is true? Well, that was false. That was false. That was false. D is true. Number 5, which of the following statements is false? All real numbers are irrational numbers. So let's check it. Is real inside? So this whole box is real, actually. Every number is real. But just because it's real doesn't mean that it's going to be rational. Well, no, it could also be irrational. So that one's false. Well, let's be done reading. So that's A. Give an example of a number that is a whole number but not natural. Guys, there's only one number. Give an example of a whole number but not a natural number. So let's go up to whole. Whole is 0, 1, 2, 3, 4, 5, so on and so forth. Natural is 1, 2, 3, 4, 5, so on and so forth. So the only number that is a whole number but not natural is 0. Give an example of a real number that is not rational. Well, that would technically be any irrational number. So we could say pi, or we could say, and I don't know how to type the square root, so I'm just going to abbreviate. Oh, it ain't going to let me abbreviate. I could say square root of 20. Oh man, maybe SR of 20, square root of 20, square root of 2, square root of 3, square root of 5, 6, 7, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20. There are a lot of irrational numbers, or pi would also work. Number 8, give an example of a rational number that is not an integer. So if we go up to rational, remember that can be fractions and decimals. So any fraction or decimal that you could think of that doesn't simplify to a whole number will work. So I'm going to say 2.5 is rational, but not an integer. Alrighty. And that's it for this sheet of paper. There's all your answers for this, and I'll post it in the PowerPoint as well.